Something that was observed since a long time ago is that different elements, when put on a flame, they have different colors. And and probably you may have experienced that if you take table salt and throw it on the flame of a stove, for example, like table salt is sodium chloride, you may observe a very characteristic orange color that is because of the sodium. So it seems like each of the elements have their own fingerprint of color. What happens if we look at this color in a little bit more detail? So what happens if in here could be the flame, it could be your flame with some sodium, or in this case there's just hydrogen. You throw it through a slit and you throw the beam of light through a prism so that you get the different wavelengths of light split on the projector, on the photographic film. What you see is a spectrum. So you will see a set of bars in here that correspond to different wavelengths or different frequencies of light. This spectrum is the fingerprint of the element. Each element has a different set of bars, has a different spectrum. So if you have, and that was for emission, but it also works for absorption, that we will talk in a minute. So a simple, the emission of potassium atoms, for example, will have this spectrum. The emission of neon atoms will have this barcode, if you will, this spectrum. And the emission of hydrogen atoms, when burned on a flame, they have this. So the main question is, where do these lines come from, and why does each element have its own fingerprint, its own spectrum? Well, this is something that we need to answer using atomic theory, and we will answer that in just the next video.